Today I want to talk about the Northern Lights, or Aurora Borealis. And specifically, I'm going to focus on the perspective of somebody trying to see them in the lower 48. There's many places where they're much easier to see, but they're much more difficult to see in the lower 48. So I want to talk about what causes aurora to form, what are some good ways to predict aurora, and then planning on how to observe aurora best, and a little bit about capturing them on film. So what causes the formation of auroras? Well, auroras are actually the interaction of charged particles hurled at the Earth from the sun. These are protons and electrons that are carried here with great speeds on solar winds. And most of these particles are deflected by the Earth's magnetic field. But the magnetic field happens to be weaker at the poles, allowing some of these charged particles to interact with gases in our atmosphere. And those interactions produce the northern lights. In fact, the different colors that we get, the greens and reds, are interactions with oxygen, and the blues and purples are actually interaction with nitrogen. And what color you get depends on how far above the Earth's surface that interaction occurs at. Our star, the sun, goes through an 11-year cycle of minimums and maximums in terms of activity. So during these maximums of activity, there's a more turbulent surface on the sun, and you get a lot more sunspots, you get more of these coronal mass ejections, both of which can produce increased Aurora Borealis activity here on Earth. And so if you're looking at opportunities to see the northern lights here in the lower 48 of the United States, the next few years looks really good, and we should be reaching our solar maximum in the next couple of years in mid-2025. Now, there are a number of websites available to help you determine whether or not aurora might be visible at your location on a given night. And realize that we're also constantly monitoring the surface of the sun and activity of the solar winds, because they do represent a potential threat to our satellite systems and to electronics here on Earth. And one of my favorites is spaceweatherlive.com. I'll put links to all of the websites featured in this video in the description below. And the first thing you're going to see when you come to this website is a multitude of information, and I just want to go over sort of the important ones here. A big one is the KP index. The KP index is a measure of disturbance in the Earth's magnetic field, and as this number gets higher, the odds are more likely that you're going to have aurora visible overhead at night. And generally, you need KP indices of greater than 3 to have much aurora activity, and to really get strong aurora in the lower 48 of the United States, you need numbers that are 5 and higher. And I'll post a little map here that kind of shows expected aurora activity based on KP indices across the lower 48. But there's some other information here that is worth going over. It also gives you probability forecasts for higher and mid latitudes, and it also gives you forecasts by day. And then as you scroll down here, you'll also get real-time data from the Discover satellite, which is monitoring the solar winds, and it gives you the estimated time of arrival of that data here in the Earth's atmosphere. And so here you'll see solar wind speeds, and generally you want to see solar wind speeds in excess of 500 kilometers per second to get good aurora formation. Over here you'll see this BT number, which is the interplanetary magnetic field. Basically, this is just a measure of the strength of the Earth's magnetic field, and higher numbers are generally better here in terms of interaction with the solar winds to produce aurora. So I really like to see numbers here closer to 10, but they do kind of tend to average right around 2 to 4 most of the time. Down here in the lower left, you'll see the solar wind density, which is basically a measure of the density of those particles. And the higher number here is better. And generally, I am looking for 10 and above on density, and in terms of getting strong aurora formation. And over here in the lower right is the interplanetary magnetic field, the BZ, which is basically a measure of the directionality of the Earth's magnetic field. And to me, this one, BZ, and solar wind speed are probably the two most important ones to me in terms of being able to see aurora in the lower 48. And it's very important that this BZ number be negative and consistently negative to get strong aurora visibility in the lower 48 of the United States. So just like any magnet that you played around with when you were a kid, the Earth's magnetic field also has polarity. And when we have strong negative polarity, you see the data just updated there, for a long period of time, that is basically channeling those particles downward towards the lower parts of North America, which gives us greater visibility, and is really pulling those particles in. So you want to see a very strong, consistent negative BZ if you're going to get good aurora visibility in the lower 48. So if I get up in the middle of the night and let's say that I have a KP rating of 5 and the solar winds are high and everything's looking good, but this BZ is very positive, I'll probably just go back to bed, because odds are you're not going to be able to see the northern lights unless you have a consistent negative BZ reading. You can also go through here and look at other information, and they will update you on geomagnetic storms. Those are basically when we get these coronal mass ejections that are coming right at us. Most of what we more typically get during these active solar cycles is we get sunspots pointed at the Earth, and in front of those sunspots you get accelerated solar winds, which carries more particles towards the Earth's atmosphere, and we get better chance at aurora formation. So I'm going to show you now where I go to look at more long-range forecasts. So I'll go to NOAA, their products and data for their space weather, and there's a lot of data here, so I just want to go over the points that matter the most. So here in the forecast section, they have a 27 and 3-day forecast. These are the two that I use the most, but there's plenty more here you can go through if you're interested. So the 3-day forecast gives you the date, and this is a UT time, so you have to adjust this. I live in the Pacific Northwest, so I have to subtract 8 hours from this. You can sort that out depending on where you live. And here this gives me the predicted KP levels for each of these 3-hour blocks from December 6th through December 8th. You can see they're all relatively low, so I don't have to worry about any aurora popping up at home for the next few days. And then I can look at the 27-day forecast, which just gives the largest KP index for each day, stretching out for the next 28 days. And you can see, like here on the 17th, there's a potential for KP of 5. That's likely because a sunspot might be pointed in our direction at that time. And then we have a series of KP 5 ratings right around the Christmas time, just after Christmas, here on the 27th and 28th. So that might be something I put on my calendar just to remind myself to check some of the websites and make sure that, and the weather, to see if maybe we might have an opportunity to get aurora on that day. Now these are just best guesses, and they're very inaccurate at times, and sometimes we get caught off guard by a coronal mass ejection, and you may only have a very short notice on when something is coming. Another really nice feature here is, especially let's say it's a night that there's a lot of potential for aurora, you can go to the models here. This is the 30-minute forecast, which predicts where aurora might be visible based on location and time of day, and you can click to play that and it'll show what the predicted aurora extent is going to be. And basically you want to see, you can see here that tonight's not going to be very good. But what you can see is you want that green area, green to yellow, to be much closer to the lower 48 border if we're going to be able to see them from here. Because remember, this is happening hundreds of miles above the Earth's atmosphere. So even if it's not directly overhead, you can still look north and see it. It's not common to have aurora directly over our heads here in the lower 48. More often than not, we're looking north and seeing aurora on the horizon. Okay, so let's go back. And then over here, we can get real-time data for those same factors that I showed you on the Space Weather Live. You can get real-time solar wind data here. And so basically, this is the same thing that I just showed you on the spaceweatherlive.com. I think theirs is a lot easier to interpret. But again, you have the density here. You have BT and BZ, so BT in black, BZ in red. You can see it's dropping in the negative there, just like it was showing. Solar wind speed here in purple. This just gives you a real-time live weather update. So just in case the data on spaceweatherlive.com goes down, you have an alternate source to get that data right here on NOAA's website as well. They all come from the same source, which is that Discover satellite. You can see where the source right there. Okay, there are several apps available that will give you access to this same information as well as additional information. My favorite is Aurora Alerts, which you see here. At the top, it gives you a % likelihood that you're going to be seeing aurora, and generally it's been pretty accurate. When I get 10% or more on the horizon, I'm generally able to pick up aurora in my cameras. Just below that, it has KP readings plus all of those factors that I talked about earlier: BT, BZ, solar wind speed, and density. It also gives you additional information on weather and moon below, but more importantly, it also provides the ability to send you text alerts when certain thresholds have been crossed. You can customize that based on recommendations in this video, and it's been really great because oftentimes I'll get caught off guard. I'll just get a text and I'll walk outside and be able to see aurora. The other app that I frequently use is my Aurora Forecast, and I primarily like this one because of its Aurora map, which superimposes the predicted aurora oval and its intensity over a Google map. So it gives me a better idea of the southern extent of the aurora oval. Okay, so let's say you've been reviewing the data and watching the forecasts, and you have a pretty good idea that there's a good chance you're going to see aurora. The next challenge is the weather going to allow you to see aurora? And in the wintertime in the northern United States, cloud cover tends to dominate our skies. But oftentimes you might be able to find gaps in the clouds. And how I do that is I go to this windy.com website, and you can look at cloud cover by clicking over here on the right, clouds. And then you can use this bottom bar here to scroll across by hour and see how cloud cover changes. And so you might be able to find gaps in the clouds. Like, so for instance, if there was going to be aurora on Wednesday night, it looks like it's going to be pretty tough to see them up in the Cascades and north central Washington, but you don't have to go very far east to get out into cloud cover. And you can click on any point and it will give you an estimated cloud cover for that site at that hour. And it's fairly accurate. I've had pretty good experience with this, being able to predict when cloud cover will exit. Now let's say that you have relatively cloud-free skies. The other issue with seeing aurora is, of course, the moon, and you can use those apps that I showed you before, or you can use a program called Stellarium. Okay, so this is Stellarium, and I'll put links to this program. It's free to download, but you can look at different objects in the sky and when they rise and fall in what direction. So you can use the search menu here. I can put the moon in, and you can show me where it's at. And then I can change by day, time, month, whatever I'm at, and look at the hour and at what time the moon rises, and then it'll also show the moon phase. You can see the moon going to full here in mid-January, and then seeing what time it rises. So you can use this to plan where the moon might be a problem for you. Full moon could be a real challenge in terms of seeing aurora because it tends to cast a lot of light into the north sky. So you want to plan your aurora hunts around those moon cycles as well. It's not impossible to see aurora if it's very strong, but if it's a faint aurora, the moon's going to make it very challenging for you to see. And finally, a major issue for a number of people in the lower 48 is dealing with light pollution. Light pollution can really cause problems in terms of aurora visibility. And in order to determine where I can find dark skies, if you're not familiar with a dark sky site, a good place to start looking is a website called the Light Pollution Map. Okay, so this is the light pollution map. Here's the United States. It's basically a heat map of light pollution, red and purples being extreme light pollution and dark areas being virtually none. And you can zoom in on areas and look for dark skies that are around where you live. In general, you're looking for rural skies or darker is my recommendation. When you get into the urban environments, it gets very challenging. And these are all based on the Bortle scale, which I can show you here by just clicking on a random spot. I live near the town of Brewster. So if I click out here, on there, it gives me the relative brightness and the Bortle class. If you click on that Bortle class, it'll help break it down. Basically, what you're looking for is Bortle class 4 or darker, so 4 or less. So 4, I live in the rural suburban transition right on the edge of rural sky. I do have a little bit of light pollution in my photos that I have to deal with, but I still am able to see the aurora without much problems. And if I really wanted to get really superb photos, I would move out to these darker sky sites. So that would be a really popular one around here is out on this plateau to the south of me. And if I click out there, you get class 2 dark skies, which is typical or average dark sky. So this is a good resource for planning where you want to shoot. And then the other thing I recommend is you also want to have a clear view to the north. You don't want a big mountain in your way. You can go out and scout out some sites looking to the north and just make sure you don't have any big obstructions to the north in terms of big mountains blocking the way or structures or trees so you can see. So far, all of those photos that you've seen in this video of those beautiful northern lights have been taken right here from my yard. And one of the things, though, I want to do is to sort of temper your expectations in terms of being able to see the northern lights with your eyes only. Certainly, there are times when aurora is visible with the naked eye. Earlier in the year, during mid-October, there was a really spectacular northern light show where I could clearly see green banding with my naked eye and also some red spikes and things like that, those spikes and towers that you'll get. But most of the time, I'm relying primarily on my camera to pick up those colors and those details. And while a lot of people might find that detracting in terms of how to experience northern lights, in the same way when I go bird watching, it's a much better experience when I use binoculars, or if I want to look at the planet Jupiter, it's a lot better experience looking at it through a telescope. So I encourage you to think of cameras as just another tool to enjoy experiencing the northern lights. Now, fortunately, nearly everybody in modern society carries a camera in their pocket on their smartphones. And you won't get like these really vivid and detailed photos like I've been sharing with you, but you can capture the northern lights on your smartphone cameras, and a lot of them have a low light or dark or nighttime setting, and I encourage you to use that. What that does is it actually allows the shutter to remain open a little bit longer and capture a little bit more light. And I'll show you some photo examples from my Pixel phone from Google, which actually has really good nighttime performance. And you can definitely see the northern lights on there. In fact, when the northern lights are faint, I'll sometimes use my phone and just turn on the camera and look around, and the glow will show up better in here than it will in my eyes at times. If you're fortunate enough to own an iPhone, especially some of the newer ones, you can actually download Adobe Lightroom and switch it to camera mode, and then you can manually control the shutter speed out to much further than you can with other phone cameras. So you can get those 10-second or more exposures that you need to get really detailed Northern Lights photos, and I'm going to be doing future videos on that. I do have an iPhone 13 on the way, and I'm going to be experimenting with photography of Northern Lights with an iPhone. Unfortunately, they have not made that available to Android users. But most of the time, for nearly all of my Northern Lights or Aurora photography, I'm utilizing my mirrorless camera, or you can use a DSLR. And what you want to look for in terms of lenses is something very wide angle. You want to be able to capture a lot of the sky, and you want something that's very fast. And what I mean by very fast is you want something with an f-stop down to 1.4 to 2.4. That's going to allow a lot more light in more rapidly so that you can capture those Northern Lights here. Oftentimes, like I said, our Northern Lights are very dim and on the northern horizon rather than typically right overhead. And having that wide angle not only makes a more pleasing photograph, but it also helps you locate the Northern Lights more quickly when you're doing your initial exposures looking for them. So what you need to do with these cameras is run them in manual mode, and it will depend a little bit on what camera you have in terms of your settings, but in general, these are the rules that I follow, and you can start from there and tweak it. But you want to have exposure times of anywhere between 6 and 15 seconds. If the Northern Lights are bright and directly overhead and fast moving, those shorter sort of 6 to 10 second exposures tend to produce the most pleasing effects for me. If you have rapidly moving Northern Lights right overhead and you leave your exposure open for 10, 12, 15 seconds, it'll get kind of smudgy, so you lose some of the detail, but you will get a lot of color, which is also pleasing. If they're far on the horizon and slow moving, then longer exposures, 10 to 15 seconds, tend to produce better results for me. I generally keep my ISO anywhere from 800 to 1600, although I tend to fall right in the middle there around 1200 most of the time. You can definitely up your ISO to amplify the colors a little bit more, but you often incorporate a little bit more noise in your image, and that's not directly related to ISO. It's a complicated video that I'll do another time. Now, one of the rules I like to use when I'm photographing the Northern Lights is the 500 rule. And the 500 rule is actually an astrophotography rule, but it has to do with how long of an exposure can you have before you get star trailing. And I don't want star trailing in the photos with my Northern Lights. I want the stars to be fine points, not these long streaky things that are going to detract from the quality of the image. And the 500 rule is essentially this: you take your focal length, that is the zoom on your lens, and 500 divided by that, and that gives you the number of seconds that you can have an exposure. So I shoot with a 16 millimeter lens, so I can easily shoot at 15 seconds and still get crisp stars in front of those Northern Lights. Now, another thing you might need, especially if you're going to be out in these long cold winter nights that we have, is you might need a dew heater. And so basically what this does is this is just a little USB powered heater that you wrap around your lens, and you can plug it into a battery bank. They're USB powered, and I can then take this and plug it into a USB bank here and turn on the heater, and that will keep dew from forming on my lenses or frost, which could ruin the images. And with this little heater here, I'll put a link to it below. I can run it off this battery bank for 7-8 hours with no issue at medium heat, and I've had it out in 20-degree weather and I've had no issues with any frost or dew forming on my lenses. So definitely a worthwhile investment. They're not expensive if you plan on spending long nights out chasing Aurora. Well, I hope this video
helped you and inspires you to get out and chase our beautiful Lady Aurora. Like I said, the next few years, the opportunities to see Aurora should keep increasing. You just have to be mindful of those upcoming opportunities, and when there's a clear night sky and there's a chance, definitely get out there and keep your eyes peeled to the north. All right, be sure to like and subscribe if you enjoyed today's content, and I'll see you out there next time. Bye.